So today we're going to be having a look at derivatives of trigonometric functions, in particular derivatives of sine and cosine. So that's what we're going to be having a look at today. So just as a quick recap, let's just think about the sine function. Now the sine function looks something like this. Starts at 0, goes up to 1, goes back to 0, goes down to -1, and back to 0. And then it repeats this process again and again and again. So this is just part of it. I'm drawing just a small piece. So I want to take a look at all of these key points along here and have a think about what would the gradient be. So the first one that's easier to do is let's do these ones that I'll do over the top in purple. What's the gradient here? Well, visually, these are all turning points. So what would the gradient be? This is sine of x. Alrighty. So what would these be? Well, the gradient here would be 0, so f dash of x would be equal to 0. We get 0 here and 0 here. What happens in between? Well, at the beginning here, the gradient would be positive, right? It's going upwards. What would it be? It ends up actually being exactly 1. It's actually, if you get a proper drawing of it, you'll see that it's a 45-degree angle, meaning, or pi on 4 degree angle, and pi on 4 radian angle, you can actually see that the gradient would be 1. And so similarly here, the gradient would be -1. Same angle going down. Up, down. So the gradients would go, right, in order, let's just write them all in, 1, 0, 1, 0, -1, 0, 1, 0, -1. So what we're looking for is that the derivative of sine, d dx, of sine of x, has got to be some kind of trig function. Why? Because it's got to be periodic. And in fact, if we do this, you'll realize that this is just the cos function, right? Cos starts at 1, goes to 0, then goes to -1, then goes to 0, then goes to 1, then goes to 0, then goes to -1. It is the cos function. Okay, so you might be hoping at this point, well then the derivative of cos must be sine. And we're going to get close to that. Let me draw my cos function. Alrighty, so cos starts at 1, goes to 0, goes to -1, goes back to 0, goes to 1, and repeats. And the beginning looks promising, right? Alrighty, so there's my beautiful picture of cos. So this is cos of x. Alrighty, so let's have a look at the gradient points. So we've got these 4 points. Well, they're all going to have a gradient of 0. And then here we have gradients. Alrighty, well this one's going to be -1, right, because it's going down. This one's going to be +1, which because it's going up. And this one's going to be -1. It's going to be down. So it's kind of like sine, but if you remember from sine, sine starts by going up to 1, not down to -1. So in fact, the derivative of cos is not sine, but is in fact negative sine. There we go. That's the derivatives of sine and cosine. Now we can do more official proofs than just a quick visual proof like this. However, in the end, we're going to get the same answer regardless. So we've got the derivative of cosine is negative sine, and the derivative of sine is cosine. So, let's do some derivatives. Alrighty. So, if y is equal to sine of x, well then, dy dx is equal to cos of x. If y is equal to cosine of x, well then dy dx must be equal to negative sine of x. Alrighty, if y is equal to negative cosine, well, remember the negative doesn't matter, the negative just comes along for the ride. So this would be equal to negative sine of x, because what does cosine go to? Cos goes to sine. So this would be equal to sine of x. D, we get y of 3 cos of x, that is dy dx would be equal to 3 negative sine of x, which is just negative 3 sine x. Alrighty, let's look at E. E is sine of 4x. Alrighty, well, this is a chain rule question, right? So dy dx is equal to, well, sine goes to cos, so cos of 4x times by the derivative of the brackets, which is 4, and we get 4 cos of 4x. F. F is y is equal to 2 cos of 4x. Alrighty, well, the 2 hangs out the front. Cos goes to negative sine 4x. But, chain rule, got to multiply by the brackets. And we get 2 negative 4 sine of 4x. And we get negative 8 sine of 4x. Lucky last one, G. We've got 2 cos of 4x plus 5 sine of x. Alrighty. Well, let's just take them separately. So we'll start off with this part of it. Now this part of it is just going to go to 2 negative sine, because cos goes to sine. Sorry, cos goes to negative sine. But then we've got to multiply by the derivative of the brackets, which is 4. Let me give them some more space. We'll do it right down the bottom here. So, 2 negative sine of 4x times the derivative of the bracket, which is 4, plus, and now let's look at the second part of it, or 5 sine of x just goes to 5 cos of x, because sine goes to cos. No chain rule needed, because the brackets is just x. Alrighty, just a bit of clean up to do. On the left hand part, this whole thing combines to being negative 8 sine 4x plus 5 cosine of x. And that is the derivative of sine and cosine. Alrighty, that's all we're looking at for today. I'll see you in the next one. Goodbye.